Hello, everybody. My name is Mark Chupka. I'm the Vice President for Research and Programs here at the Energy Storage Association. Thank you for attending today's webinar on creating a domestic supply chain for advanced batteries. This webinar is being recorded, and everyone who registered will also receive a link to the recording and slides within the next couple of days. Questions can be submitted at any time via the questions chat box in your browser, and we'll get to those after our speakers finish their presentations. In the text of your question, please indicate to whom you would like your question addressed. All meetings and teleconferences of the Energy Storage Association are held in accordance with our antitrust guidelines. We ask that you abide by these guidelines during today's webinar. The full guidelines are available in the members area of the ESA website. If you are not already an ESA member and would like more information, you can reach out to my colleague, Brenda Lovell. Membership includes free access to all of our webinars, including many that are exclusively for members, among numerous other benefits. Please contact Brenda for more information. Before we begin, I'd like to announce some upcoming ESA events. The first part of the ESA Annual Energy Storage Conference will be a virtual conference on April 21st and 22nd, which is free to attend. So please check the ESA website for updates and registration information. Tomorrow, ESA is co-hosting a webinar with National Hydropower Association on pairing battery energy storage with hydropower resources. Today, we are exploring a very timely and newsworthy topic. Before we hear from the panel, we have a special guest who will explain the importance of the battery supply chain to the Biden administration. Before being named Special Assistant to the President for Climate Change, Phil Giudice has been a clean energy pioneer, a policy expert, and an entrepreneur. And as far as I can tell, Phil is the first energy storage industry veteran ever to be appointed to the White House staff. We are extremely grateful to have him open this webinar. Phil, I'll turn it over to you.
Thank you, Mark, and thank you for the invitation to be with you all today. I am very excited for the work that you are doing, the outcomes that you're achieving, and the work that we're going to be able to do together. I see it as a tremendous opportunity to build great global winning domestic businesses and industries. This is my third week at the White House. I'm excited to be part of the team, which I have found to be incredibly smart, experienced, practical, committed, and that we universally share a sense of urgency to get this done as soon as possible. And by this, I was particularly drawn to joining this effort by the very clear focus on achieving 100% carbon pollution-free power sector by 2035. This team is not okay with just making minor changes for decades and then hoping that some miracle will occur and in the later decades to get to our needed outcomes. Storage, as you know and I know, will be a big part of achieving the outcomes that we need to get to happen. So we can do a lot now, and we need to find and use every available lever to make the progress happen now and then accelerate on that progress as we move forward. Biden administration is bringing a whole of government approach to these challenges, and I would let you know that I am excited by the reactions and receptivity that has come from all across the government, DOD, DOE, Department of Ag, DOI, state, FERC, every element, GSA, folks are excited by the challenge in front of us. This won't be easy. This won't be perfect, but this is important. And I encourage all of us to be loud and proud of what we are getting done together, and look forward to finding ways to work with you to grow great jobs in America, build great business, transform our power sector and our entire economy. And with this successes in doing that, we will have an opportunity to lead the world as to what we know we need to get done. And so those are just a few remarks to hopefully cheer you all on. I am involved in the power sector executive order around supply chain for batteries, along with many colleagues from the NSC, the NEC, and others, DOE. as well as looking at all of the elements of the clean energy manufacturing supply chains as to where the best levers are to try and help along. So I encourage you to be in contact with Mark as to your suggestions for the opportunities that we can work together and make things happen. And I look forward to getting that input and taking it into all of our considerations. Again, thank you for the work that you're doing and cheer you on for getting a lot more done over the coming years. Thanks, Mark.
Well, thank you, Phil. We really appreciate you taking some time to address us and to inspire us. We appreciate it.
You're welcome. Look forward to staying in touch with you all. Thank you.
All right, take care. All right, well, I am delighted to introduce an excellent panel for today's discussion. First up will be Mitali Gupta, who is a senior analyst for energy storage at Wood Mackenzie Power and Renewables. She will describe the basics of the global battery supply chain, including how stationary energy storage systems compare and compete with electric vehicle batteries for resources. Julie Blunden will be next. She is the board chair at New Energy Nexus Catalyst. Julie will examine the raw material and battery manufacturing potential of the U.S. and what might help stimulate investment in a domestic supply chain. I'd also like to take this opportunity to thank Julie for helping put together this webinar today. And our final presenter is Cameron Dales, who is the Chief Operating Officer at Enovix. Cam will relate a case study of how Enovix is developing battery manufacturing capability in the U.S. and the lessons learned from their success thus far. After their remarks, we'll open up to the audience Q&A. You can ask questions via the question chat box at any time, and we'll read those out for the presenters when we get to the Q&A session at the end. Just a quick warning, we'll probably go over our allotted time of 1 hour by a few minutes in order to get some questions that otherwise might not be answered. And now I'll turn it over to Mitali.
Great. Thank you so much, Mark. Hello, everyone. I'm Mitali Gupta. I am an analyst with Wood Mackenzie. And yeah, I would like to begin by firstly thanking ESA for inviting me to present here at this webinar today. As Mark mentioned, and as Phil mentioned in his remarks, this is a very timely topic, and we're definitely excited to be a part of this discussion today. So in my presentation today, I'm going to sort of set the stage a little bit, talk about the energy storage market, the stationary storage market in the U.S., and then from there sort of talk a little bit about the global battery supply chain. So what's happening across the globe in terms of battery manufacturing, how the supply chain has sort of been evolving under the pandemic, and what's happening in other parts of the world with regards to lithium-ion battery manufacturing. Before I get started, just want to take a minute to talk briefly about my company. So Wood Mackenzie, we are a market research and intelligence firm providing market analysis on a variety of topics, ranging all the way from solar, energy storage, wind to other topics such as subsurface chemicals, metals and mining, battery raw materials, and such. We are a global company and have more than 500 sector-dedicated analysts covering different topics across the world. So with that, talking a little bit about the energy storage market in the U.S. So the U.S. energy storage market saw record deployments in 2020, despite the pandemic, and more than 1.4 gigawatts of energy storage was deployed in the U.S. across all three market segments. So when I say market segments, I'm basically referring to front-of-the-meter market and behind-the-meter market, which includes your non-residential systems and residential systems. Front-of-the-meter market surged quite rapidly, especially in the second half of 2020, and residential market also continued to see tremendous growth. However, non-residential markets struggled a little bit because of COVID-19 setbacks that hit the market early on in 2020. Looking forward, so at Wood Mackenzie, we do forecast the market 5 years out. And as you can see on this chart in front of you, we expect the market to reach 7.8 gigawatts of energy storage deployments annually by 2025. This 7.8 gigawatts by 2025 represents almost five-fold growth in the market compared to 2020. Deployments will jump dramatically in 2021, driven by large-scale utility procurement. The front-of-the-meter market segment will make up for about 84% of market deployments next year, and residential and non-residential markets will continue to accelerate. So whenever we talk about energy storage, obviously we look at gigawatts, but it's also important to consider gigawatt hours or megawatt hours. So over here you can see we do track the market in both megawatt hours, gigawatt hours as well. So the market in the U.S. saw as much as 3.5 gigawatt hours of deployments in 2020, which was about 200% growth over 2019. By 2025, the annual U.S. energy storage market will grow by almost 8 times, reaching more than 27 gigawatt hours of annual deployments by 2025. The systems are continuing to get longer in duration, essentially because system costs are continuing to decline. There is greater need for system flexibility. Renewable shifting is becoming more and more apparent, and as a result of this, we are seeing increases in discharge durations for systems, and thus the megawatt hours are sort of increasing as well. So not only are we breaking down the market in terms of deployment numbers, but we do look at technologies as well. So here I want to shed a little bit of light on what kind of technology deployments we have seen in the U.S. market. As you can see on this chart in front of you, lithium-ion has sort of been the dominant technology in the market since 2016. Other technologies like lead acid, sodium chemistries, flow batteries have seen some level of deployments, but really it's lithium-ion batteries which have continued to sort of dominate the market. In Q4 of 2020, the market was 100% lithium-ion batteries in terms of deployment, which thus shows that there's a huge potential for improving the supply chain for lithium-ion batteries within the U.S. And I'm going to talk about that in a little bit. So up until now, I've mostly been talking about energy storage market and what kind of growth we expect to see in this market going forward. However, it's also important to look at the bigger picture. So where does the energy storage market sit in comparison to some of the other demand sectors for lithium-ion batteries? So as you all know, lithium-ion batteries are largely going to the EV industry right now. So EVs will sort of continue to make the lion's share of global lithium-ion battery demand over the course of even next 10 years. Demand for portable electronics has seen a significant drop over the past few years. It was at about 26% of the global demand in 2020, and it will drop down to about 6% by 2030. So it means it's both EVs and energy storage markets that are beginning to take off, that are going to dominate the lithium-ion battery demand over the next few years. But beyond what's happening in terms of the market demand, it's also important to consider what's happening with batteries specifically. So like I mentioned earlier, majority of the lithium-ion batteries have been going to the EV market, and energy storage market has sort of reaped the benefits of that, whereas the cost of batteries for EVs has come down, the cost of batteries for energy storage has also come down, and system costs have continued to decline in the energy storage space. However, now as the energy storage market is becoming more mature, we are seeing energy storage deployments and a variety of applications happen for energy storage. There is a demand of batteries that is sort of improving in the market, as a result of which we are seeing different performance requirements come out of the energy storage space. The batteries needed for energy storage now require longer life, greater cycling, safety, and other attributes are sort of coming to the surface. And as a result of this, we expect this divergence on the horizon for both batteries for EVs and stationary storage market. In terms of technology, this could mean that we will probably see different kinds of chemistries for stationary storage market, and for EV markets, this could mean that we would probably see different kinds of metals being used in these batteries. So it could be anything, but we are definitely seeing these two sort of industries and market segments separate out from one another going forward. So in terms of supply chain, how does it look today, and how is it expected to grow over the next few years? So at Wood Mackenzie, we also track global lithium-ion battery manufacturing, and as you can see on this chart in front of you, planned lithium-ion battery capacity will reach more than 1,500 gigawatt hours by 2025 and will reach more than 1,800 gigawatt hours by 2030. One thing that I would like to mention is the numbers that you have on this slide is really the pipeline of capacities that have been announced or are currently under construction. Asia Pacific, as you can see, sort of dominates the market right now. So it accounts for about 80% of the global lithium-ion capacity. China, obviously, is sort of the dominant country over there, which has a capacity of about 350 gigawatt hours today, and it is on track to reaching more than 1,000 gigawatt hours by 2025. So there's a huge growth curve that China has set up itself for, and battery manufacturing is ramping up pretty quickly in China. Europe is also invested heavily in ramping up their share of battery manufacturing. A lot of it is driven by the European Battery Alliance that has been supporting local development of batteries across the region. Also, with the surging EV market in the U.S., countries have come to realize that it makes more sense to have a more localized supply chain, as a result of which we are seeing significant investments happen across countries in Europe. And Europe currently accounts for about 7 to 8% of the global manufacturing pipeline, and this number will reach about 20% of the global pipeline by 2030. So a lot of things have sort of happened over the course of past few years. This is just one example in terms of when COVID-19 hit China. Because majority of the capacity, lithium-ion battery capacity, is sitting today in China, more than 150 gigawatt hours of battery manufacturing capacity was at threat. When factory closures were announced in China back in February 2019, in order to avoid human-to-human transmission of the virus, there were a lot of travel bans, shipping delays, factory closures. All those things led to significant capacity coming to threat. That also impacted the global market, because there was a fear in the market that if these factory closures continue for a long time, there would be a battery supply tightness in the market. However, a lot of those issues resolved pretty quickly once these travel bans and factory closures were uplifted, and the battery manufacturing supply chain was able to recover from that pretty swiftly. However, early on in the year, there was a threat when the virus hit China. So, as you can see, while a lot of Chinese vendors have sort of recovered pretty swiftly, both UK and US are sort of making progress around localizing their supply chain. So, like I mentioned, the pandemic was just sort of one example of how the supply chain was at threat last year. There have been other instances as well where battery supply chain has seen some tightness. So currently, even right now, there is some supply tightness coming from China, where a lot of vendors are operating at capacity, and there is some supply tightness that is being experienced by the energy storage market here in the US. Even before the pandemic, back in 2018 and 2019, when the South Korean market saw a huge surge in energy storage deployments, there was a supply tightness for batteries in the markets outside of Asia, because a lot of South Korean vendors started preferring their own market and started supplying batteries to their own market, and as a result of which there was a supply shortage in the markets outside of South Korea. So, like I said, there have been several instances where supply tightness has been seen by the storage market. A lot of it also comes from the fact because EVs make up for the majority share of lithium-ion batteries, vendors try to prioritize EVs over energy storage, as a result of which the market is sort of left behind. However, as the market continues to grow, as the demand for batteries continue to grow in the stationary storage market, the localizing the supply chain would enable energy storage market to keep ramping up in the future. So with that, I would once again like to thank ESA for having me on this panel today, and I would now pass it on to Julie for her remarks. Thank you.
Thanks so much, Mitali. That was a great job. So first of all, Julie Blunden with New Energy Nexus. So happy to be partnering with ESA to make this event happen. The timing could not be better. New Energy Nexus accelerates and incubates clean energy entrepreneurs around the world, and we quite literally wrote the book called Accelerate This. And boy, is that appropriate. Over the next 24 months, we will determine what the United States share and breadth of the global battery manufacturing supply chain is going to look like. That 24 months starts yesterday. We're in the process right now of making decisions about who the partners are going to be for auto manufacturers and stationary storage manufacturing companies, for where we're going to put supply chains, how far back into the supply chain we're going to invest in the United States, geographically where that investment will be, and therefore where the jobs will be. It's a pretty important time. We're making fundamental decisions right now about how to de-risk our battery supply chain that has implications for everything from our Defense Department to our power grid to our transportation sector. This is quite a moment. So with that, I will make every effort to move the next slide forward. Yay. All right, so early 2020s right now anchors that mass volume supply chains. We've obviously had supply chains for battery manufacturing for some time, but the scale, as Mitali was describing, as you can see on the left, is literally an order of magnitude between 2020 and 2030 globally, with passenger electric vehicles dominating that effort, commercial vehicles and some other vehicles overwhelming the question of where the batteries are made relative to stationary storage. However, stationary storage will benefit from transportation electrification radically, because the cost reduction associated with economies of scale will benefit not only the transportation electrification effort, but also stationary storage. As Mitali usefully illuminated, China really does and has, since, if you go back to the history, since about the early 90s, has been planning to dominate the transportation electrification efforts, electrified vehicles, and the supply chain. And they're doing a heck of a job of it, actually. Between 2/3 and 80% of most of the components of battery manufacturing supply chain are currently held in China. And if you look at upstream manufacturing there on the left column, you'll notice that's only 23%, but it's sort of somewhat disingenuous at first glance, because China's also gone and bought into the mining companies that mine in places like South America and Australia. Lithium itself is not really the problem. There's plenty of lithium supply. The question is really, where do you recover that lithium, and where do you anchor the supply chain in the world, and specifically for the US domestically, in order for us to truly build a new industrial infrastructure domestically. If you look at what happened in solar, it's a cautionary tale. I was directly involved in this effort beginning in the early 2000s, and joined a company where I actually wrote their S1 to go public in 2005. If you look on the left side, what we did is open up the US capital markets, and we funded the scaling of the photovoltaic industry manufacturing supply chains in China, not exclusively, but heavily. On the left side, you'll see the US share in the blue line drops from north of 40% to under 10% between 1995 and 2010. But even more tellingly is to look at what happened between about 2005 and 2010. That's when China turned on their investments. And when they did, they went from a de minimis share of market for PV manufacturing in 2005, when we opened up the IPO market, to a dominant position of over 50% in 2010. When you scale that forward by another decade, you'll see on the right, the pie chart, China in 2019 had a 71% share of global PV module production. So that's not a terrible thing. The scaling that we saw in China definitely drove down solar prices and radically transformed the power sector, both behind the meter and in front of the meter. But what we did is we made a default decision to not invest in the United States in a complete way so that we could de-risk our solar supply chain. And during the last year, we suffered for it. If you look at where we are right now with gigafactories, gigafactories is a generic term, exact scale to be determined by the speaker. Nevertheless, the point of the matter here is that we're looking at China being, on the scale of 100 and the US at being less than 5 in 2020. And that's why President Biden a month ago said, if we don't get moving, they're going to eat our lunch. If you look on the left side, what you see is the lithium-ion battery cell manufacturing, and you'll see how it's very heavily concentrated in China. But you'll also see in Europe that we do have some investment there. What you see in the United States is basically Tesla and almost nothing else today. If you look at the component manufacturing, it's a very similar story. And so the question is not just where are the actual battery packs assembled, but the complete supply chain. And now is the time to answer the question of where and how much we're going to invest in the United States. Europe has already made a bunch of decisions. In fact, Northvolt, which is kind of the national champion of Europe, has raised just last week another $200 million that brings them to $3.8 billion raised. They are aiming for a 25% share of the European battery market. I think that's an important statistic. What they're saying is it's not 75%, it's not even 50%, but it's a material portion. If you add a few more competitors in there, you're looking at something that could be 30 to 50% of batteries made in Europe for Europeans, and that's an important statistic. On the right-hand side there, what you see is that in about 2030, you'd be aiming for base case, call it 40 gigafactories. What Northvolt is saying is that they're aiming for about 10 by 2030. They're already operating in Europe and rapidly ramping up. Fundamentally, the message here is the US is behind. However, the US DOE has been paying attention, and during the last administration, they released just before Christmas the Energy Storage Grand Challenge Roadmap. And this slide comes from that report. And it specifically highlights that domestic manufacturing is a vital component of energy and national security. That means not just innovate here, which is what we did for solar, but also to make it here and deploy it everywhere. The roadmap is actually quite good, and there's a bunch of material. If you haven't spent time looking at the Energy Storage Grand Challenge and you're interested in these subjects, I've included links here, as I have on all the slides, where you can get more information. So where are we right now? We are in seed stage, I would frame it. It's not that we have zero battery manufacturing and component manufacturing in the US, but outside of Tesla, we have extremely small amounts. Now we do have plans. What you'll see on the left-hand side here is the major global manufacturers listed in the table. And I've somewhat clunkily added in which states those major manufacturers have indicated that they either have manufacturing today, they are in construction, or they have plans. It is true that 6 out of 10 of the major global manufacturers for batteries are investing in the United States, and you can see on the right where those are. However, 4 out of 10 have not. And we have conflict between LG and SK in particular around the investment in Georgia, where there's 2 plants. And that is really playing out right now and has major implications for both Ford and Volkswagen, 2 major auto manufacturers with major US operations. So I would call it a choppy time. And the question of exactly where those sites end up being built is still in formation. But the formation will be figured out here in the next, call it 3 to 9 months, in my best estimation. And I expect that we're going to see a bifurcation of that investment. The battery manufacturing and components will be close to the automakers, whereas the lithium production and chemical processing of lithium will happen near the source. So there'll be transportation between the two, but with far less carbon intensity than if we handle all of that activity in multiple jurisdictions around the world. When you think about our lithium worldwide, you will note that the US is actually really well endowed with lithium. In fact, arguably better than China. Southern Cone in Australia are major manufacturers today. China is coming up very quickly, and the US has tremendous resources. Let me tell you about one in particular. California's Lithium Valley, where New Energy Nexus has been actively involved in enabling the implementation of recovery of lithium, very different than what we see lithium supplies look like in the rest of the world, has been successful in that we're now seeing both DOE and Energy Commission funded pilot plants. Before I explain Lithium Valley, let me just say that we also see lithium activity in other states. You've heard a lot about Nevada probably, but also we're seeing North Carolina and Arkansas, for example. So this is not unique to California, but what is unique to California is that lithium recovery can be done out of the Salton Sea geothermal power plant brine as a secondary use of both existing and planned geothermal generation. That's cool. That means a small footprint, low water intensity, 90% less than in South America, in an economically disadvantaged area, one of the hardest hit areas with COVID in the country, actually. And the Blue Ribbon Commission that was formed as a result of state legislation last year was launched last month. The resources for lithium from recovered geothermal brine could be 30% of today's global demand. That is magnificent. And that's with our current view. It is a real opportunity for us to anchor a domestic supply chain of lithium in Southern California, serving the rest of the United States. New Energy Nexus wrote a report about this. Link is below. So what next for making sure that we take full advantage of the next 24 months? Well, first and foremost, demand pull. US auto manufacturers, both those headquartered in the US and those headquartered elsewhere, but with US auto manufacturing, need to say right now that we want to see de-risked supply chains. That means a portion of their supply chains are completely housed in the United States domestically. Technology funding is very important. Public funding is coming out of potentially legislation like the Green Act and the Clean Act, the DOE Loan Program Office, other DOE programs and other agency programs, but we're also seeing the SPAC capital on top of that, which can't be underestimated. That provides very strong and useful private sector fundings to accelerate activity, including those that you're going to hear about from Cam in just a minute. I also want to give a shout out to the technology accelerators. New Energy Nexus runs several programs in the United States, including National Lab CRADAs. If you are interested in using existing resources at national labs, for example, Berkeley, Lawrence Livermore, and SLAC, please let us know. We have existing CRADAs that allow you to get up and operating in labs in 6 weeks instead of 6 months. It's been very successful. Berkeley Labs worked with us over a dozen times. We also run Cal Seed and Cal Testbed. If you're interested in seed stage or early stage funding, please see those programs. They are publicly funded and super cool. We have awesome, awesome companies coming through our technology accelerators. Fundamentally, though, we need to also really focus on impediment removal. How do you make sure that when you have a company that has a great technology that could accelerate, improve, and lower costs for batteries, be U.S. invested, U.S. jobs, we need to make sure that they have every opportunity to succeed. I'd like to hand things now to Cameron Dales from Enovix, super cool company in my sort of hometown of Silicon Valley, doing cool stuff and actually moving towards manufacturing in the United States right now. Cam, over to you.
Great, thank you so much for that, Julie, and wanted to express my appreciation for ESA for having me on the program today, and especially wanted to thank Julie and our partners over at CalCharge and the New Energy Nexus. This group has been just a huge supporter of companies like ours. We've been a part of that since the very beginning, really, of our company as a startup. Primarily because we very much believe in the need for an overall ecosystem to support companies all up and down the supply chain, and that's just critical for the success of startups like us, as well as the more established players. So with that, wanted to introduce Enovix to the audience. We've been fairly under the radar through our history. We've been quite successful in terms of the economic relationships we've developed with customers. We've raised a significant amount of money, well over $500 million, but have been up until now really heads down on the technology. So many may not know us, so I'll spend a little bit of time just giving you some background as to who we are, and then give you some insight into our thinking for how to site our manufacturing, why we decided to put our first factory and potentially our second factory in the U.S., what the challenges are for making that type of a decision, and what the opportunities are. So with that, a couple of disclaimers. From an overview perspective, Enovix was founded in 2007. We've designed and developed and have now sampled breakthrough high energy density lithium-ion batteries that are significantly ahead of where traditional lithium-ion batteries are today. We have a technology based on silicon anodes. Many of you may be familiar with that. We have a particular approach to that through the design of our cell itself, the cell architecture to handle some of the issues with silicon. We're sampling now to over 20 customers with 4 different products. And I'll spend some time talking about our approach to entering the market with a new technology. We think that's a very important part of a successful path with a new technology into the market. Everybody knows energy storage is not easy. We've been at it for 13 years. We've spent almost $250 million on R&D. One of the key challenges to any new technology and any energy storage technology is access to capital. Our approach to that has really been through strategic funding sources. Over half our funding has come from strategic partners who have a direct demonstrated need for better batteries. And then, we've had tremendous support from the customer side, and this will perhaps shed some light onto why we chose a certain strategy that we did in terms of how to enter the market. Quickly on our technology, as I mentioned up front, we have an architectural approach to pushing the energy density of lithium-ion batteries. Really, the whole company is based on this, what we call three-dimensional architecture. It has some advantages, both in terms of the space efficiency, which is important in certain markets, and in the ability to make a silicon anode work, which has fairly significant materials problems of expansion and contraction as you charge and discharge. So our approach to that is, rather than try to invent a new material, it's to use existing silicon materials, but to manage the challenges with silicon in the form of the silicon 3D architecture. I won't get into the details of that, but really the design of the cell is meant to allow the expansion and contraction of silicon inside and we encapsulate the cell with a structural constraint that manages the stack pressure of the cell, ultimately leading to high cycle life. So that's a little background on the cell. You know, we're not the only ones who think that the future of lithium-ion batteries is with an anode made of silicon. This is Elon Musk and Drew Baglino at Battery Day at Tesla. They also think silicon is awesome and inexpensive, and so do we. So a lot of horsepower going towards this approach in the market. So let's talk about the technology space. We're a technology company first. If you think about areas that are important in technology, the mega trends that are really driving technology business forward, everyone's aware of 5G cell phones. This is a massive problem from a battery perspective in that market. I'm sure most of you have smartwatches or some other wearable fitness tracker devices. So the idea of putting computers on our bodies and wearing them is something that's gained traction. Big market just on its own will be $100 billion by 2027. Big battery problem there. And then as we think further out into the future, there's a tremendous amount of interest among the really large and small technology companies about what is the next big computing platform, you know, from mainframe computers to PCs to laptops to the computer in your pocket, which is a phone, to what is really the next platform. And folks like Tim Cook at Apple, Mark Zuckerberg at Facebook, these guys think this could, the next big platform could be this AR, VR space. And again, this is a market that doesn't exist today, partly because of a massive need for better performance out of the batteries that power these things. And then finally, of course, you know, a lot of discussion about electric vehicles and the transportation revolution that's underway. So how we think about these markets from a small, you know, startup technology company perspective has a lot to do with the value that each of the markets puts on improvements in battery technology. So you can see in each of these markets, the cost per watt hour, the price per watt hour in the market from a battery perspective is very different. And so from our perspective, this is key to understanding how we are entering the market, how we intend to scale. Our first factory is under construction now. It's in Fremont, California, and I'll talk specifically about why we put it there. It's called, perhaps not unimaginatively, Fab 1. We'll enter the market in these higher value segments first, scale into what are really quite large markets in phones and laptop PCs with our first and second factory. And then in parallel, we are working with companies to adapt the technology to the larger, massive mega markets that you see in EVs and in the grid. And so the question from a strategy perspective is, if you want to impact, larger societal goals around climate change and carbon footprint, et cetera, and you want to support electric vehicles and the grid storage and ultimately build a supply chain here in the U.S., what's the best approach? Our answer to that question is not to necessarily focus our company directly on those massive commodity markets where cost and scale are primary, but to first enter markets where we can build a profitable scaling business, and then in parallel to that, enter the larger commodity markets where cost is really the driver and cost at scale is the key factor of success, to do that as a second step. So that's maybe different than how policy choices and governmental support often thinks about the problem. We want to throw money at putting new technology into EVs, but from a pure business perspective, that's an incredibly difficult road to get to the scale and ultimately the cost structure that you need to be successful. So there was some good discussion of the market size up front. I would challenge anybody to find a market that is growing at this rate and at this size as the lithium-ion battery market is today. And again, our approach is to first go after the premium segments, which on its own is a $13 billion market. There was a comment made earlier that the percentage of the electronics space in terms of lithium-ion battery markets is shrinking, and that's mainly because the growth in EV and in grid. But on its own, it's still a fantastic starting point for a company like ours to go build a competitive business, achieve scale, which is required no matter what your technology is to compete from a cost perspective, and then ultimately use that scale and the cost advantage that we think our product has to go back and enter the large EV and grid spaces. So it's a bit of a two-step process or a stepping stone process to get into the market. But from our perspective, we think this is the rational way to go. And one of the challenges from a policy perspective is how to, knowing that the end goal from a societal perspective is the the reduction of carbon footprint, the transition to EV and grid storage, but how to enable companies that have a real competitive advantage and an advantage in technology to become thriving businesses and ultimately impact at that scale. So from with that, our fab scale up, and we'll talk a little bit about our first factory in Fremont. We have a phased approach. So our first factory is under construction now. We'll go into production early next year. I'll share a little bit of details about that and talk specifically about why we sited it where we did in Fremont, in Silicon Valley, which is not perhaps the most economical place to do manufacturing in the world, but we think there's some key advantages to that. We have a second phase that we're actively working on now. Our manufacturing technology is built on the overall kind of lithium-ion supply chain platform. And so there's some opportunities to essentially retrofit existing factory assets that are out there in the world to produce batteries according to our architecture. Won't spend too much time on that. But then third phase, of course, is what we've been talking about here, which is moving this technology, which has significant performance and cost advantages in theory, but needs to be realized at scale, and doing that in partnership with some of the existing suppliers. So that's our strategy. This is our first factory. It's in Fremont. It's right across 880 from the Tesla car manufacturing plant. Has an R&D footprint in the middle, and then most of the outer ring of the building is where the factory itself will be. A little bit of background on our manufacturing technology. As I mentioned, it's built on the overall lithium-ion battery supply chain. The front end of the process is essentially identical to making lithium-ion cells, so it's coated cathode and anode electrodes. We have a unique material in the anode. It's a silicon oxide material, but for the most part, it leverages the supply chain both from a materials perspective and a manufacturing perspective of traditional lithium-ion manufacturing. Our piece is really in this middle 30% of the process, where we have a different way of assembling the cell, and that's what you're seeing in the pictures above. We do some pretty interesting laser processing to structure the electrodes and pattern them, and then have a high-speed roll-to-roll process that creates that 3D structure. Back end is again the same as a traditional lithium-ion space, and so that we think is really important in terms of achieving the scale and leveraging the billions, if not trillions, of dollars of investment that's gone into lithium-ion batteries. And then, an important aside here is that we consciously chose to try to make our technology as close to the existing lithium-ion supply chain as possible, just because of the cost implications that has. And if you think back to Julie's example of the solar space, I think there's a real analogy there where, if you remember back, silicon solar cells, of course, were first to the market, but there were many startups and different technologies that on paper had a lower cost structure than silicon. But in the end, once the industry reaches a certain tipping point of investment, the scale advantage that the incumbent technology achieves is so difficult to overcome from a cost perspective. And so you see that even though from an efficiency perspective or from a theoretical cost perspective, the silicon solar cell may not have been the winner, but it achieved scale first. And we see a similar story playing out in energy storage, where the scale and the investment that's gone into lithium-ion supply chains is so huge that even if you have a lower cost, newer technology, if you don't leverage that, it becomes very, very difficult to hit the cost targets to ultimately create a winning business. Just a couple of quick pictures of our factory to give you some perspective on that. This is our R&D area. We've built and tested over 20,000 batteries there and ultimately produce prototype products that are sampling to customers. This is a shot of the factory itself. So in December, you can see it's a two-story with a mezzanine factory that's basically under construction. Here's a picture from a few weeks ago as the equipment for production is starting to roll into the factory. So we'll be integrating those lines over the next couple of quarters and then going through a qualification process on the cells and moving into commercial production early next year. So, let me just summarize then by talking a little bit about why Enovix decided to locate the factory where we did, and how we see ultimately competing and entering the market successfully from a business perspective. Because even given the best policy environment out there, if you can't build a business that makes money, ultimately it's not going to survive. So from a why perspective, when we look at the market, particularly in energy storage and batteries, our viewpoint as a startup is, we must have a significant innovation advantage. Our product needs to have a significant competitive advantage. In our case, that's energy density, which ultimately can lead to lower cost. But again, you need to get to scale. And from a strategy perspective, our belief is that in order to continue to compete from a high cost location like the United States against commodity suppliers who are often very significantly supported by their home governments, China, Korea, good examples. We feel to be successful, we not only have to have a better product today, but we have to maintain that innovation advantage over the long term. And how do you do that? So there's some great work that was done by some folks, Pisano and a gentleman named Willie Shih out of Harvard and MIT in the late 90s, early 2000s. And really the core of their thesis is that there's a lot of information in this chart here, and I won't go through it all, but for certain types of industries, you can separate the manufacturing from the product and the product innovation. A good example of that is semiconductors, where you can design chips and have an advantage in design, and then you can ship that overseas or to some other location where it gets manufactured, and the process of making it is quite different from the innovation advantage that you have. In an industry like solar cells, in an industry like batteries, the innovation that goes into that product is heavily dependent on the process and the manufacturing process that you use to make the product. And so the core of their thesis, and we've seen this play out over and over again, is that even if you invent the technology and innovate it in one location, for instance, if we support through the DOE innovation in energy storage, if we then don't ultimately manufacture that technology in the same location where that innovation happens, because it's so tied to manufacturing, the innovation actually moves, and the know-how and the engineering moves to wherever that manufacturing footprint is. And you saw that play out in solar. We certainly saw it play out in the early history of lithium-ion batteries, where, of course, the initial technology for lithium-ion was invented here in the U.S., but up until the stimulus days, there was essentially zero manufacturing footprint for batteries here. Why? And why did the innovation then ultimately move to where the manufacturing sites are? It's because of this linkage between, the R&D side and the manufacturing side. And in fact, there's a two-way street. It's not just R&D explaining to the manufacturing factory how to, produce the product, but there's a two-way street where that information transfers back from manufacturing to R&D. And so the key strategic decision for Enovix was, if we think the only way to thrive as a business is to maintain our innovation advantage, we felt that we had to put our manufacturing footprint co-located with our R&D. so that we can get to generation 2 and generation 3 and ultimately compete successfully. So that's a key point of strategy. And then the second question is, okay, well, if you're going to locate your factory in a location where there's not yet a thriving supply chain and ecosystem, because it had already moved offshore, and you're going to have a cost disadvantage in the beginning because of scale, partly. How do you successfully enter the market? And this really drives the approach to start with a profitable premium business and then leverage that at scale into the larger markets that are very cost driven. And so that's what we've done. We have 5 design wins now at leading companies in essentially the consumer electronics space. You can see these 5 here. And then as we enter the market there, we will scale into our second factory, our third factory, and ultimately move into the larger but very cost sensitive markets in EV and grid. So that's a little bit about how we think about innovation and how we think about building a business that can survive and win and ultimately impact the large goals of climate change. But we think that it requires starting in parts of the market that are amenable to new companies and are where you can have a competitive advantage that is strong enough that ultimately allows you to overcome the disadvantages of locating in a place that doesn't yet have a real thriving ecosystem. That said, I think the whole purpose of the discussion today and the mission of the organizations that are speaking today is to develop that ecosystem so that there's a supply chain that starts from the commodity minerals. We build a thriving secondary chemical business for supplying of cathodes and anodes and things like that, which we would use in our products, and then ultimately develop a thriving set of businesses around cell manufacturing where there are real, competitive advantages that can be maintained over the long run. So with that, let me just end and turn it over to Mark. One quick advertisement: we do have a white paper that we put out that really kind of talks about this in some detail. So if you want to take a deeper dive, please check our website in the next day or two. This should be up on the website, and you guys can take a look at it.
That's great. Thanks, Cam. Those were excellent presentations, everyone. We have some questions that have come in. I'm going to extend the time of this webinar by 5, maybe 10 minutes so that we can get to some of these questions. I'll ask the presenters to keep their answers somewhat brief. There's a question, so earlier on in the presentation, this is Mitali, directed to Mitali. The question is, with the demand for lithium-ion batteries in EVs, does this make the opportunity for non-lithium ion solutions more desirable in energy storage, stationary storage applications?
Thanks, Mark. And that's a great question. So, interestingly, yes. And to the point that I made regarding divergence between the two markets, so like I said earlier, we are beginning to see that divergence happen in the EV space and the energy storage market, where the performance requirements of the batteries are sort of changing. And as the market is increasingly looking at longer discharge durations and bigger systems, it definitely opens the door for some of the other non-lithium technologies as well. So lithium-ion is not a one-size-fits-all solution, if you may. It does help achieve the applications that we are trying to target today. But as the market demand continues to grow, as we see value stacking, customers asking for a variety of applications, looking at seasonal storage, overnight storage, eventually it will make way for some of these other non-lithium-ion technologies that tend to perform better at longer discharge durations, and the economics definitely works out better when you're looking at bigger systems.
All right, thanks. That's excellent. Appreciate it. So this is for Julie. Julie, you cited 24 months as sort of a critical time period in which, you know, winners and losers will be determined in the supply chain race. Is there what is it pure first mover advantage in getting to scale first, or are there other dimensions of this time frame in terms of who's going to dominate? And a secondary question is this just in, does this 24-month time period apply to all aspects of the supply chain, or in some of the links more than others?
Excellent question. I would say that let's speak specifically to the US right now. We are expecting to see substantial upticks in volume of commercial electric vehicles, both number of models, number of manufacturers, OEMs that don't currently deploy in the United States that will in the future, and the manufacturing to support all that. That's a 2023 start date. It's not that we aren't seeing electric vehicles out the door today, we are, but on a commercial volume basis, remember that Tesla was 80% last year, 80% the year before. They're going to be in that vein this year and probably next. It won't really change until 2023, and that is a function of the US being a distant third market compared to China and Europe. We don't have the policy in place, have not had the policy in place that puts us on an even playing field for expressing the demand in the market. Once you realize that 2023 is the starting time, you have to back up and say, when do contracts have to be in place? When does dirt have to move? When will the entire supply chain create that demand pull? And the answer is about 2 years prior. So 2021 is the time for the entire supply chain to be anchored. It doesn't mean, I mean, when you think about what those volume charts look like, 23 through 30, there's a huge amount of growth that happens through the end of the decade and beyond. But right now, those anchor seating places are being discussed in Zoom calls across the industry. And so I would say that there's a very high probability that the locations of automobile, electric vehicle manufacturing will determine battery locations for manufacturing, but not the lithium locations. Lithium locations are going to be a function of how far along people are at figuring out how to do lithium extraction through the different spodumene deposits and geothermal brine locations in the United States. That's a different race, but it's on the same time frame.
Thanks, Julie. It's perfect. I've got a question for Cam. What is the competitive landscape in the higher value markets? Is it performance? Is it innovation? And how does Enovix plan to win those markets first as a stepping stone to other markets?
Sure. Yeah, it's a great question. In the premium markets, or at least the markets that we have chosen to go after, this is really portable electronics broadly, not only consumer, but these are devices that you carry around with you. Because of the portability factor, this is the primary competitive feature that we're essentially competing with is energy density, either volumetric energy density or gravimetric energy density. So the amount of capacity of your cell divided by its volume. And interestingly, the reason why there's so much premium to be had in those markets is that, it's not just a matter of, your phone lasts longer, before you have to recharge it. Most OEMs will actually not choose to do that. If you can offer them a higher performing battery in terms of energy density, what they will do is they will use that additional power budget to add features and functionality to their product, which is absolutely something they will compete in the market against their competitors with, or they'll choose to make their product smaller and lighter, which in some use cases is again, a very significant competitive advantage for them. So this is what allows that market to, or allows us to go access and compete and win in that market, even when we have all the disadvantages of a startup company, right? I mean, a startup company has millions of disadvantages. You don't have a track record. Your costs are high because your scale is low. You're unproven, you know, et cetera, et cetera. You need to have some incredible advantage that you offer your customers, which allows them to look past all of those things and place a bet on your product. Because if it pays out, it's a massive financial win for them in the market. So that's the dynamic that is going on in that space, and that's certainly the you know, the thought process that the customers we're working with are using.
Great, thank you. I've got one final question, which any or all of the panelists might usefully address. Talk about the end of the life of the batteries. How much does the sort of circular economy or recycling and reintroduction into the supply chain factor into your thinking about domestic supply chains?
This is Julie. I can say that recycling of lithium-ion batteries is integral to most automakers and therefore their suppliers thinking pretty much from the get-go. I think that's fantastic. The sort of downside / upside of this whole thing is the average life of a car is, call it 11 to 15 years. Maybe it'll be on the longer side with electric vehicles. However, you're going to have, as we've seen already in the United States, a certain amount of scrap coming out of battery manufacturers that allows recycling to get off the ground, even though we won't see real volumes of batteries to be recycled in, you know, material ways that can actually change what we need from a mining perspective or recovery perspective until the mid-2030s. So you can't ignore it now, but the impact on what we need to do to build a supply chain from raw materials today is only minutely adjusted by even outstanding recycling practices.
Yeah, I definitely agree with what Julie mentioned. And from a storage perspective, I would say we are seeing some partnerships and some pilot programs that have been launched to bring back some of these used EV batteries for second life applications in the storage market. However, having said that, this whole process of repurposing used EV batteries to storage applications, it's a very complex process, and it comes with a host of its own economical and technical challenges. Because again, like, you are looking at variabilities in battery packs and racks, different chemistries, different sizes, and due to the lack of standardization, there is still a series of challenges that a lot of these vendors are facing for the storage market. But as the global stockpile for batteries continues to grow, there is a huge opportunity for both, like Julie said, for recycling, but also for second life applications in the storage space.
Okay, thanks. You know, we've arrived at the end of our time, and I'd like to thank the panelists for a fantastic set of presentations and some very interesting insights. Before we conclude, I'd like to remind you to register for the ESA Energy Storage Virtual Conference on April 21st and 22nd, and have a great rest of the day. Stay safe and healthy, and we'll see you next time.
Thank you.
Thanks, Mark. Appreciate it.